All right, this is lesson 3.8 of our Pre-Calc 12 class. The unit is called Exponential and Logarithmic Functions. Lesson 8 in particular is called Properties of Logs. And this is kind of like what I think is the fun stuff of logs. What we're going to do is add and subtract logs, and we use these properties to expand and condense these logs. So here are the 4 properties we're going to work with. In the next couple lessons, we'll primarily work with the first 3, and then the 4th one will come in at the end of the unit. But we're going to show them all right now. So the product rule is log base a of x times y. We can split that up to be log base a of x plus log base a of y. The quotient rule is log base a of x divided by y, and that is equal to log base a of x minus log base a of y. The power rule is log base a of x to the power of c, and that's equal to c times log base a of x. And the base rule is log base y of x is equal to log base a of x over log base a of y. So let's talk about each of these a little bit and then we'll move on. So the first 2 ones, you can kind of think about them as we think about, because logs are just a different way to write exponentials. So if we think of our exponent properties, if I have some a to the power of x and I multiply it by a to the power of y, well that's the thing. We have same base multiplying means we can add the exponents. So it'd be a to the power of x plus a to the power of y. So when I say log, the log kind of represents an exponent. So we can think of adding the exponents from our exponent properties. Quotient rule, we can think of log base a to the power of x divided by, we can think of a to the power of x divided by a to the power of y. Well, that would be a to the power of x minus y. So you kind of see some pattern there between the exponent rules and our log rules. Okay, power rule, we have basically if the thing we're taking a log of has an exponent, I can take that exponent and put it out front as a coefficient of the log function. And then our last rule, basically we can take our base and we can write this log as a fraction of logs, and we can change the base to be whatever base we want it to be. This is particularly helpful when we want to calculate the decimal value of a log, but we only have a ghetto calculator that only does just the base log function. So nicer calculators lets you type in any base you want of a log, but the old calculators or basic calculators just do log or log base 10. Let's look at some examples. So if I want to expand these logs as much as possible, here are our log properties we're going to use, and again primarily the first 3. Log of 5x squared. Well, 5 times x squared, that can be written as a log of 5 plus log of x squared. And x squared, we have an exponent on the x, so we can use our power rule for logs. We can bring that, instead of c, we have 2. We can bring that 2 out front as a coefficient of log of x. So here's fully expanded for that one. Log of x cubed times y would be log of x cubed plus log of y. And since the x cubed has a power of 3, we can bring that 3 out front as a coefficient of log of x. Okay, this next one we're using our quotient rule for logs. Log of x to the power of 5 divided by y to the power of 2 would be log of x to the power of 5 minus log of y to the power of 2. And then we can bring each of those exponents out front of their respective log functions and make them coefficients. So 5 times log of x minus 2 times log of y. Okay, here's one example with base rule. So if I have log of base x to the power of y to the, log base x of y squared would be log of y squared divided by log of x. And then the exponent on the y I could bring out front as a coefficient. So here are 4 examples of expanding logarithms. And so now next we'll look at condensing them, so basically working backwards. And the reason why I want to work backwards in these ones, my thing I'm taking a log of are just numbers, so we can rewrite this as a much simpler log. Okay, so then if we look at this guy, log base b of 9 plus log base b of 3. Since they have common bases, we can use our log properties. Log base be equal to log base b of 9 times 3, which would be log base b of 27. 9 times 3 is 27. Log base b of 9 minus log base b of 3. Well, that would be our second property. We would do log base b of 9 divided by 3, which would be log base b of 3. In our third example, we have a 2 coefficient, so I can make that 2 the exponent on our 5. So this would be log base b of 5 to the power of 2, which would be log base b of 25. I'm going to use a couple properties on the next one. I'm going to start with my coefficient of 3 and make that an exponent of the 2. So we'd have log base b of 6 plus log base b of 2 to the power of 3, which would be log base b of 6 plus log base b of 8. And now I've taken care of the coefficient, and so I'm going to take these logs with the same base and put them as one log. So it would be log base b of 6 times 8, which would equal log base b of 48. The next one is 5 log base x of 2 minus log base x of 8. And first step, I'm going to bring that 5 coefficient as an exponent on the 2. And then since I'm subtracting log with the same base, I'm going to make that 5 over 2, or 5 to the power of 2 is going to turn to 32, and 32 over 8 is going to give me log base x of 4. So here's 5 examples with condensing a log down to a single log function. Okay, so what we learned in this lesson is we can use these log properties to expand and condense logarithms.